And so we'll just go ahead and dive right in. Let me share my other screen, and then we can begin. Okay. All right. Okay, so today we're going to get into compositions. So what we've looked at so far is different types of rigid transformations. Remember that a rigid transformation preserves the angle, measures, and lengths of each geometric figure. So the shape doesn't change, the size of the shape doesn't change, just the location might change or the orientation might change, but the actual shape itself doesn't change very much. And so far, we've looked at three types of rigid transformations: translations, reflections, and rotations. Those are all the different types of rigid transformations that we've seen so far. So what a composition basically is going to be, it's going to be a sequence of transformations that occur one after the other. So basically, a composition of transformations is a combination of two or more transformations performed in sequence. So for example, we can have a rotation and then a reflection, a translation, and then a rotation. So it's just multiple types of these transformations happening one after the other. And the way that we represent them is what you see here, where you see this would be read reflection across line M, composite. This represents our composite, the composition of it. So we're doing it in sequence. A reflection about point E prime, 90 degrees. So the way that we read compositions is from left to right. From right to left. So the rightmost transformation always goes first and then the leftmost. So basically that means that the reflection would go first and then the rotation. So we read the compositions the opposite way in which we normally read text. So we would go from the rightmost to the leftmost. Okay. So here you see that transformation taking place. We start with our pre-image. Our pre-image does not contain that prime notation. And the way that we know which transformation comes first and which one comes second is our first image after a transformation will have one prime notation. And then our image after the second transformation will have two prime notations. So basically, this will be our first transformation and this will be our second. Okay, so the first thing we need to do is a reflection across line M, which we see happening right here. And then after that, you see a reflection about point E prime, 90 degrees. Okay. Any questions about this? So from right to left, that's how we read it, from right to left. So for example, here we have a reflection and a translation. So we're being asked to perform the given transformation that we see here. So we have a composite, a composition of transformations. So what we want to do is read it from right to left. So the first one we'll do is the reflection. That tells us reflection across line M. That'll be our first one. And then because we're going from right to left, our next one will be a translation. And we know how to read this. This tells us a translation. We don't move any way right or left because it's a 0, but we do move 3 units downward because we have a negative B. Okay, so if I wanted to perform that here, the first one would be a reflection across line M. So it will look something like this. Let me see if I can draw that a little better. Okay, right there. So that's my first transformation, which is my reflection across line M. And so I can label this W prime, X prime, Z and Y would stay the same. Okay. And I just can use one prime notation because that's my first transformation. Okay, what's my next transformation? My next transformation tells me to translate 3 units down. So I can say that I can move this 3 units down like this. So say, oops, I moved it 3 units down. And so now this would be my Z. And I would put 2 prime notations because that is my, oh my God, my image after my second transformation. And so therefore, my resulting image after those 2 transformations would be this red one right here. Okay. So that's basically how I'd apply both of those transformations. Any questions about this? Questions, concerns? Okay. So the order in which we apply these composite or compositions is very important, because if you don't do it from right to left, you'll end up with a completely different resulting image. So for example, here we see the same transformations, but one happens before the other. So whenever we read composites, we read it from right to left. So the first thing that will happen here is a reflection across line M, which we see right here. This is number 1, reflection across line M. And then the second thing will be the rotation about point G prime, negative 90 degrees. Okay, so this would be my resulting image after that composition of transformations. Okay. Well, here we see the same transformations taking place, but the order in which they're put is changed. So instead of a reflection first, we do a rotation first. So this is our rotation. And then after that, we want to do a reflection because it tells us to do so there. So this would be 2. And so what you see is that those 2 images, depending on the way that you read those compositions, it changes, right? Like the location of your resulting image would change. Oops, that's not what I'm looking. That's not the one. This is the one right here. That is not 2. This is 2. My mistake. This is 2. Okay. And so that's why it's super important for you to remember that whenever you have compositions, you got to read it from right to left. Always right to left. Because if you miss up the order, you'll end up with a completely different resulting image. Okay? So rigid transformations in the coordinate plane can be represented using mapping rules, which we've seen. We've seen the mapping rules for reflections, the mapping rules for translations, and the mapping rules for rotations. And this is just a reminder of those different mapping rules. For reflections, we have mapping rules for reflection across the x-axis, the y-axis, y equals x, y equals negative x. Depending on the type of reflection you have, that changes, which we've looked at. For translations, it is represented like this, where this A tells us what happens to our x value, y tells us what happens to our y value. A is us moving left and right. B is us moving up and down. And then for rotations, we have specific mapping rules too for 90, 180, 270. Okay. And if you have any questions about this, you can go ahead and review those PowerPoints for when we went over reflections, translations, and rotations. Okay. Okay, so let's look at a type of problem we might encounter here. This one says, what are the vertices for the final image after applying the composition? And we read these compositions from right to left. So after composition, first thing is a rotation about the origin, 180 degrees. And then the second thing is our translation, -2 and 4. Okay, so we read it from right to left. So the first thing we want to do is apply the rotation. And then after we apply the rotation, we apply the translation. So give me 1 second. So I can show you what we're doing here. So basically what we're doing is we are applying this composition to the different coordinates to find out where the resulting vertices are after the final transformation. So we start with our pre-image. Our pre-image does not contain the prime notation, so we'll start here. The coordinates of our pre-image, x, y, and z. X is at 2 and 5, y is at 4 and 3, and z is at 2 and 3. The next thing we want to do is apply our first transformation, right to left. So we're going to do the rotation about the origin 180 degrees. Whenever we have a rotation about the origin 180 degrees, we simply negate the x and y. So it becomes -2, -5, -4, -3, -2, -3. So that is this image right here. This is our image after our first transformation. Okay? Now we're looking for our image, the final image after our second transformation, which is a translation. So what we're going to do is we are going to subtract 2 from x and add 4 to y. And that gives us the following coordinates. And therefore, we have -4, 1, that is our y, -4 and -1, that is our x, double prime, because that's our second transformation, and then z is going to be -6 and 1, which is about right here. And therefore, you'd be able to create your image after both of those transformations. Okay, so basically you can use the mapping rules to find where those vertices or those coordinates map to after those different rotations or transformations. Okay. Any questions about this? Again, reading it from right to left. Right to left. Okay. So transformations can be composed into a sequence of transformations, which is compositions. The order in which the transformations are applied is extremely important. The rightmost transformation always needs to be applied first. Okay? And knowing that, you're able to apply mapping rules to find vertices, or you're able to see those transformations taking place here, where you want the rightmost to happen first, the leftmost to happen second. Okay? Any questions about anything we went over today? And we'll go over some example problems tomorrow. But if there's no other questions, you guys may log off, and I'll see you guys tomorrow. Bye, guys.